Hello everybody and welcome back. Today I'm going to talk about electronics, especially the principles of voltage, current and resistance. So it will be a 3 parts video. This is part number 1. And each time I will use some analogy to explain you these principles. To understand the concept of voltage, current, and resistance, we can use the Onslow model. The Onslow model being an electronic model that describes the link between these 3 parameters. To understand the Ohm's law, we use most of the time the analogy of a river dam. A river dam is a structure used to stock water. On this picture, you can see a cross-section view of a river dam. On the upstream side of a river dam, we instinctively know that the deeper we are, the bigger the pressure is. The physical reason behind is simply because of the weight of column of water. Imagine now the following mental experience. Suppose the quantity of water on the upstream side of the river dam is infinite. Now create in your mind 3 same openings on the river dam, but at different depths. Because of that, you know that water will run through these openings. But you also know that the flow will be different. As you can see on the picture, we understand that the opening at the minimum depth will have the lowest flow and vice versa. Before we go further, I would like to make a quick parenthesis to remind the definition of flow. In our case, the flow is the quantity of water unit that run through a surface section that what we define, like for example the opening on the river dam, by unit of time. So by water unit, I can say that it could be a liter, and unit of time can be second, minute, or hour. So just for example, we could use in our case the unit of liter per second. So now this parenthesis is closed, so we can think about this other mental experience. So let's create an opening at a definite depth of a river dam. Keeping this in mind, now enlarge the opening of the river dam. Although the pressure stays exactly the same, we know by experience that the flow will increase. Enlarge once again the opening and the flow still increases. Now let's summarize. We have seen that the flow is proportional to pressure. And for definite pressure, we have seen that the flow is proportional to the opening. Let's define now the notion of resistance to flow. We know that the smallest the opening is, the most difficult it is for water to run through it. This notion of difficulty of water to run through the opening can be named as the resistance to flow. So we can say that the notion of opening is simply inversely proportional to the resistance to flow. By deduction, we can now conclude that the flow is inversely proportional to the resistance to flow. The flow being proportional to the pressure and being also proportional to the inverse of the resistance to flow, we can say that the flow is proportional to the product of pressure by the inverse of the resistance to flow. By rebuilding differently this equation, we now have the following relation up to a factor, which says that the pressure is equal to the resistance to flow multiplied by the flow. This up to a factor is indeed incorporated in the term of resistance to flow, which means that we do not use anymore the term of proportionality, but the term of equality. Now appears the interest of using the river dams analogy. In this analogy, we link the concept of voltage to the concept of pressure, the concept of current to the concept of flow, and the concept of resistance to the one of resistance to flow. We have finally the physical relation voltage is equal to resistance multiplied by the current, a relation known as the Ohm's law. Although this equivalence seems very helpful, and it is, there might be another analogy that could help you to better figure out the notions of voltage, current, and resistance. I invite you now to see the second part of this video, not available the day I posted this video, but which should be very soon enough.